So we're keeping on talking about limits, but now we're talking about a specific type of limit, which is an infinite limit. And if you look at the examples in 1, 2, 3, 4, you can see at the bottom there, it's just saying the limit as n or x or whatever the variable is approaching infinity. So these are obviously going to be a little bit different than what we've been looking at because we've already always looked at a specific value. As it says up here, a key fact to evaluate infinite limits is any number when we divide it by infinity is equal to 0. So that's kind of an identity that we want to kind of, you can memorize it or you can kind of think logically about it. So if you imagine any number, let's say 2 divided by 10. Okay, so that's going to be 0.2. Let's take that number and I'm going to divide it by a number that's bigger. So 0.02. All right, now let's take it and keep going. Remember, we're going to try and come up to infinity. So that's going to be 0.002. And you'll notice that these numbers, the bigger my denominator gets, the smaller my answer actually gets. And so eventually, if I were to continue to go, it's going to be 0.0000000 infinity, which is basically just going to limit down to 0. Our answer is going to be 0. So if you kind of think logically about it, it does make a lot of sense. There are 4 important infinite limits. And again, a lot of these just kind of come by common sense if you just even do exactly what I did up there in the red. It's saying the limit as n is approaching infinity of c, and remember c is a constant, is c. Now this makes sense. We've kind of already talked about this. So if I take a look at this example, if our constant is 7, remember how we were saying before in another lesson that this is going to be a straight line, right? Where every single point is equal to 7. And that's going to go on to infinity. So even if I choose, you know, infinity here as my value, which technically isn't really a specific value, but we know that no matter what, I'm going to get that value of 7, no matter what. So I know my answer is just going to remain as that constant. So that rule hasn't changed since when I've talked about it before. The next one is when I've got the limit as n is approaching infinity of 1 over n, so basically infinity, to the power of r is equal to 0, where r is greater than 0. So r is going to be 1, 2, 3, whatever. So if we look at this example, we've got, again, n is approaching infinity, 1 divided by n to the power of 2. Well, again, guys, you can imagine that this number is just going to get bigger and bigger and bigger, right? So if I take a look at kind of a pattern here, 1 over 1, 1 over 4, because I'm squaring everything. Let's look at the perfect squares. 1 over 9, 1 over 16, all of these numbers up to 1 over infinity, right? That, looking at this identity up here, kind of makes sense that my answer is just going to be 0 because, again, 1 divided by a huge number is going to be very, very close to just 0. The next one is when we're dealing with fractions. So if r is in between -1 and +1, so basically r is going to be a fraction or a decimal, 0 point something, we know that when r is to the power of n and n is approaching infinity, again, our answer is going to be 0. And this works very similar to the second, like number 2 that we just did. So for example, if I've got 1 over 3 to the power of n and n is approaching infinity, that means it's just getting bigger and bigger, right? So I'll start with 1 over 3 to the power of 1, 1 over 3 to the power of 2, 1 over 3 to the power of 3, and so on and so on. And again, you're going to see that 1 divided by a really, really, really big number, such as infinity, is just going to give us a 0. Okay, so again, pretty logical. Number 4, the last one here. Again, this one's just kind of obvious, where it's saying if r is greater than 1 or less than -1, so basically it can be a whole number or 1 point something or 2 point something, our limit does not exist. And so it's saying that r is, again, a whole number to the power of n. So if you think, guys, that's going to be huge, right? Like if I look at this example, 4, let's start off with 4 to the power of 1, 4 to the power of 2, 4 to the power of 3, 4 to the power of 4, and so on and so on and so on. That number is going to eventually reach infinity, It's just going to go on forever. It's just going to continue to get bigger and bigger. So that means that there's no specific answer for n. So we could say, or I'm sorry, for that limit. So we could say infinity, or we could also say does not exist. So those of you having a tough time kind of wrapping your head around this, don't forget you can always go to the help desk, but also just take a look at maybe some more examples and just see, you'll notice some patterns, and even use your calculator to help you, and you'll see that numbers are either approaching 0 or infinity. The next little bit is talking about how we can actually evaluate these limits, and we might be able to simplify and do a few things. And again, just remembering that 1 over infinity is equal to 0. This is kind of that key on the last page that we want to remember. So if I look at this first example here, so the limit as n is approaching infinity, and you're given an actual, function here, n over n plus 1. How do we evaluate that? Well, take a look at the strategy here. It says divide the top and bottom of the fraction by the largest power or degree. So the largest power. When you evaluate the limit, any expression in the form 1 over n to the power of r will be 0. And again, this is basically saying 1 over infinity is equal to 0. So let's do that. Again, I know it kind of seems weird, but you'll see how this simplifies in just a minute. So we want to take a look at what the largest power is in this example. Well, obviously it's just n, right? Because this is all n to the power of 1. And we're going to divide every single term by n to the power of 1. So I've got n over n divided by n over n plus 1 over n. So again, you're seeing that we're dividing everything by that n. And what you're going to notice is that obviously we can simplify some stuff, right? So n divided by n is just going to be 1. N divided by n is going to be 1. So this is going to be the limit as n is approaching infinity of 1 over 1 plus 1 over n. Now when I plug in my value, okay, so we've done all the simplifying that we can possibly do. When I actually substitute in n is approaching infinity, or n equals infinity, remember 1 over n, or 1 over infinity, is going to be 0. So this is going to simplify to just 1 over 1, which is just going to be equal to 1. So again, if your head is spinning, what did we do? We looked for the highest power, and again, we only do this when our limit is approaching infinity. It's kind of got its own special method. We take a look for the highest power, and we divide every single term by that highest power. And there is going to be some things that are going to cancel out and simplify and make our life a little bit nicer. So let's look at the second one. Take a look, guys. What is the highest power that you see? Hopefully you can see n to the power of 4, right? So we're going to take everything, so our limit as n is approaching infinity, and we're going to divide everything by n to the power of 4. Okay, and now we can simplify, and you're going to see some things are going to cancel. Like basically we've got these guys and these guys are going to cancel. So I'm left with limit as n is approaching infinity. I've got 3 minus, well, n, and that's going to become cubed. So that's going to be 2 over n cubed plus 1 over n to the power of 4. That one's not going to simplify. Over 8 minus, and that one again is not going to simplify. So we're just left with 7 over n to the power of 4. Now, once we've done that first step, once we've found the highest power and we've divided everything by it, now what we can do is use the identity. Remember this guy here, super, super important. 1 over infinity is equal to 0. So any number divided by infinity is equal to 0. So this is going to become 0, right? Because 2 divided by infinity. 1 divided by infinity is going to become 0. 7 divided by infinity is going to become 0. So all we're going to be left with is actually 3 over 8. And that's going to be our limit of that function, 3 over 8. Okay? So again, let that kind of sink in what we're doing. And you might want to, like if you're not understanding this, you might want to pause it there and just kind of like redo them, go over them. Because in the next little bit, it's kind of like a shortcut. You will notice something. And you will notice, again, some patterns in these limits of where the highest power lies. So basically, now it does say memorize. You don't have to memorize that if you don't want to, because what we just did here is going to work every single time. So you just take the highest power, you divide everything, you do it the long way, and you're good to go. And you're always going to end up with that limit. Or if you like shortcuts and you've got a really good memory, you can take a look at this table and say, okay, well, if the top degree is equal to the bottom degree, so basically this guy and this guy, if those are the same, then the limit is the coefficient of the highest degree terms. So if I look at this one, again, if I kind of do it the long way, I've got n squared, so the highest power is n squared, right? So I divide everything by n squared. And I know that this is just going to cancel out, so I'm just left with my 1 there. This n over n squared is going to leave me with 1 over n. These are going to cancel, and that I can simplify. So we're left with 1 minus 1 over n over 2 plus 1 over n squared. Well, obviously this guy and this guy are both going to become zeros. So my answer would be a half. Now, let's take a look at what the shortcut says. If the top degree equals the bottom degree, which it does, the highest power is in both the numerator and the denominator, the limit is the coefficients, so the numbers in front, of the highest degree terms. Well, if we look at that, the highest degree terms, that's a 1 and that's a 2. So right away, I knew my answer was going to be 1 over 2 because of that little rule. Again, as you can see, you don't have to memorize the shortcuts. You can do it the long way. The next little shortcut, if the top degree is less than the bottom degree, so the top degree, you can see the highest top degree is less than the bottom degree. Or you could kind of look at that as the highest degree is in your denominator only. Okay, you can also look at it that way. Then your limit is going to be 0. So right away, this shortcut is saying, yep, I know it's going to be 0 because that's in there. Well, if we look at it kind of the long way, I know my highest power is the 7, so that's going to be 4n5 over n7 minus 3n squared over n7 plus 9 over n7 over 2n7 over n7 plus 6 over n7. Now again, if I kind of think ahead a little bit, now you guys should start to be thinking, okay, how are these patterns actually working? You know that you're going to end up with an n on the bottom of this first one, right? Like n to the power of 5 and n squared. And if I think ahead, if I put my infinity into the n, I'm going to have 4 divided by n, so that's going to be a 0. Same thing over here. N squared divided by n to the power of 7, that's going to be gone. I'm going to be left with an n in my denominator, and anything divided by infinity is 0. Same thing with this one. This one, I've got n to the power of 7 and n to the power of 7. Those are going to cancel out, so I'm just left with a 2. And then this guy is also going to become a 0. So 0 plus 0 plus 0 is 0 on the top and 2 on the bottom. So 0 divided by 2 is 0. So I know that this answer is actually 0. Okay? And the last one, if my top degree is greater than my bottom degree, or basically another way of looking at that is saying, okay, my highest power is in my numerator only. Well, if it's in my numerator only, again, I can draw that the long way. This is saying the limit does not exist. So that must mean that we're dividing by 0 or something funky is going on. So this is my highest power. Let's divide everything by that. We'll look at it again the long way. So 2n squared over n to the power of 5 plus 7 over n to the power of 5. And again, let's kind of take a shortcut here as well. And we're going to see what's going to become 0. So n to the power of 5, n to the power of 5 is just going to become 1. Right? So that's gone. N squared and n to the power of 5 is going to become n cubed on the bottom. So if I get rid of that, I've got 3 divided by n cubed. When n is infinity, that's going to be a 0. Same thing here, that's going to be a 0. Same thing here, that's going to be a 0. And same thing here, that's going to be a 0. So this would simplify to 1 over 0, which does not exist. Okay, so that's how that works. So again, keep in mind, long way always works, shortcut always works. It just depends on your preference. So a few more questions to practice this. Again, what I would recommend that you guys do right now is just pause this, do these on your own, and then double check the answers when you're all finished. So I'm going to do a variation of the shortcut and the long way of doing this because this stuff, it's not that difficult once you practice it. Again, here, you'll notice that my highest power is in both my numerator and my denominator. Right away, those of you that have a good memory should know that your answer is going to be 3 over 5 because that's the coefficient of those higher powers. If your head is spinning and you're like, oh, I'm not good at remembering things, don't forget, just do it the long way. And any time that you're going to have a variable in your denominator, you know, like left over in your denominator, that's going to be equal to 0. So these are going to be gone. This is going to be 0. This is going to be 0. This is going to be 0. And that's going to be 0. So you're just left again with your 3 over 5, no matter what method you choose to use. In this case, I can see that my denominator is in, my highest power is in my denominator. So right away, you might say, okay, well, I know that the answer is going to be 0. Well, and again, that was your shortcut that you could see on the last page. The long way-ish, you can see how quick this is. It doesn't take that long. Over x cubed over x cubed plus x squared over x cubed minus 1 over x cubed. Again, anytime you have a denominator that's going to have a variable in it, it's going to be equal to 0. 0. These cancel, so that's going to be 1, 0, 0. So this is going to be 0 over 1, which obviously is 0. Next one, you can see again that my denominator has the highest power in it. So right away, I'm just going to take the shortcut because I think we've done enough of those. Right away, if it's in the denominator, you know that your answer, I'm going to be having a 0 on the top, and we're going to have basically like a -2 on the bottom, which is going to give us a 0. Now the last limit, again, if I look, n to the power of 4 minus 5n cubed plus ... That just means that it's a continuous function. It's going to go on forever, divided by n squared plus ... or sorry, 9n squared. And this, guys, you don't have to overthink it. Again, you can just see my highest power is in my numerator. So right away, I'm going to have a number up there, and I'm going to have nothing on the bottom. So that automatically tells me, doesn't matter if it goes on forever, the limit definitely does not exist. So go ahead and practice page 50. Okay, there's one more lesson and then this learning guide is finished. So you guys want to make sure that you're practicing everything because the last lesson is a little bit different than what we've been looking at.